Okay, so this is the lecture for empirical formula. Today is December 12th, and what I'm going to show you guys is what the empirical formula is, and then how to calculate it based off of percent composition by mass, which we've learned already. Okay, so basically the empirical formula is the simplest or most reduced ratio of atoms within a compound. Okay, it's a way to write it in the most basic way, so the most reduced way possible. The way to determine the empirical formula is you want to base all your calculations on 100 grams of a compound. So if you're given the formula, or within the problem, if they give you the percentages, you turn those percentages into grams, and then you calculate it based off that. The second step is then to determine the moles of each element within those 100 grams. And then the final step is to divide each value of moles by the smallest value that you just calculated. So it might be a little bit confusing, at least at first, but when we do a few practice problems, it'll make more sense. Okay, so let's say that we have, we want to find out the empirical formula for a compound that is 48.38% carbon, 8.12% hydrogen, and 43.5% oxygen. So the first step is we want to turn each of these percentages into grams. So we have now, instead of 48.38%, you have 48.38 grams of carbon. You have 8.12 grams of hydrogen, and you have 43.5 grams of oxygen. Okay, now from here, it's just a basic converting this into moles. So it's basic factor label, nothing new from what we've learned. So you do your times goes into with each of these three, and on the bottom you're putting grams, and it's grams of carbon. So the periodic table would tell us that that's 12.01 grams. Okay, on the top goes 1 mole. You do the same for hydrogen, which is 1.01 grams, and the same for oxygen, which is 16.00 grams. You don't double these. I know typically we've been doubling hydrogen and oxygen because they're diatomic elements, but these are technically within a compound. They're not by themselves, so you would not double them. Okay, all of these are going to be under 1 mole. Okay, so then once you have it set up from here, you're doing your math on your calculator. So for the first one, we're doing 48.38 divided by 12.01. Oops. Which equals 4.028 moles. Don't worry about rounding here. We can wait till round until the very end. Next we have 8.12 divided by 1.01. So this is 8.039 moles. And then finally we have 43.5 divided by 16, and you get 2.718. Okay, so now the third step says, out of these three numbers, which is the lowest? Okay, and obviously 2.78 being the lowest. So that's the number that you would then divide for each of these to figure out your empirical formula. So I'm going to divide this value by 2.78718, sorry. Divide this by 2.718, Divide this by 2.718. Okay, obviously this value equals 1. Okay, the 8.039, we got to do in a calculator, so 8.039 divided by 2.718. So this equals 2.95. And then the top value, which is 4.028 divided by 2.718 equals 1.48. Okay, so now here, what we have is values that aren't quite whole. Okay, so this one obviously is whole. 2.95 we can round to 3, but this value is 1.48, which is basically 1.5. You can kind of round it to. Now, if you don't have a number that's really close to a whole number, like 2.9 or 1.9 or 8.9, if you have something that's dead set in the center, you have to multiply that number, which we'll say is 1.5, by the lowest possible number to produce a whole number. So the lowest possible number to multiply 1.5 by is 2. 2 times 1.5 is 3. Okay, but now you have to do that for everything. So hydrogen you multiply by 2. So that gets us 6. And then oxygen you multiply by 2. And obviously that gets you 2. So now you have your values. You have 3, 6, and 2. Okay, so that's your formula. So your formula now is C3H6O2. Okay, so that's one possible way that you would run into a problem, is basing this off of percentages. If all of these numbers came to whole numbers, like if this, let's say this was a 2, this turned out to be a 3, and then that just we stayed as 1, you would then, you wouldn't have to multiply. Okay, so we're kind of doing maybe the trickiest version of these types of problems first. But let's look at the next one. Okay, so here you have a 50.51 gram sample of a compound has been made from phosphorus and chlorine, and it was decomposed. The analysis of the products showed that 11.39 grams of phosphorus atoms were produced. They want to know what the empirical formula of the compound is. So you have to do a little bit of math up front here. Okay, you have the total sample, and then they're giving you just the product of phosphorus. Okay, so we know phosphorus is 11.39, but to figure out chlorine, we have to subtract this total from just the phosphorus. Okay, so we do 50.51 minus 11.39. Okay, so I'm subtracting these two. Get the calculator back. Okay, so 50.51 minus 11.39. So I have 39.12. And what this represents is the mass of chlorine. Okay, so the way that this problem is different from the previous problem is instead of percentages, you're given the gram amounts, which is fine. It's still going to act in the same way. Okay, so what I'll start with then is I have 39.12 grams of chlorine. Okay, and then the other value I have is 11.39 grams of phosphorus. Okay, so it's set up the same way now. So we want to convert this gram amount into moles. So I have grams, on top goes moles and moles. Okay, the molar mass of chlorine is 35.45. The molar mass of phosphorus is 30.97. Okay, so on the top goes 1 mole, 1 mole. All right, so now here we're at the point where we do the math. So for the first one, you go 39.12 divided by 35.45. And you get 1.1035. Okay, again, you don't have to worry about rounding. Just leave it. Don't worry about sig figs. We're okay. Okay, now for the next one, we do 11.39 divided by 30.97. And we get 0.3677 moles. Okay, so now that we've converted to moles, we got to figure out which value is the smallest. It's fairly easy. It's going to be the 0.3677. So we round by we divide by 0.3677 to both values. Okay, this is obviously going to be 1, and then 1.1035 divided by 0.3677 comes to 3.00108. So we're going to round that value to 3 because it's very close to it. Okay, so both of these numbers are close enough. There's nothing that's in between. There's no 3.5s, there's no 1.5s. So we assign the 3 to the chlorine and the 1 to the phosphorus. So my formula now is PCl3, and that would be the empirical formula. Okay, I hope this helps. I'll post another video from a different teacher to kind of show you how to calculate empirical formula with more examples if this is still kind of confusing. Okay, thank you very much.